This is a Venn diagram problem review. So there were 130 people surveyed, and 37 got relief from drug A only, 4 got relief from all 3 drugs, A, B, and C, 9 got relief from B and C only, 11 got relief from A and C only, 25 got relief from B only, 44 got relief from C, and 40 from B. So A only would put 37 in this region. 4 from all 3 is in the center where the 3 circles intersect. B and C only does not include A, so that would be 9 here. A and C only does not include B, puts 11 in here. 25 from B only is here. 44 from C. Well, we already have 11 and 4 and 9, so we have 11 and 13 is 24. From the 44 from C would put 20 in here. In B has 40, we have 25, and 13 is 38. From 40 puts 2 in this region. Now I would take and total, let's say C is 44. That's those 4 regions, and then I would add on the other 3. 37, and then 2 is 83, and 83 and 25 makes 108. And subtract from 130 puts 22 in this region. You need to enclose the problem in a rectangle because now I can ask certain questions. For example, I can say how many got relief from B and C. Without the word only, it's the region for B and C, which is 13. If I say A and B, then that would be the region that would be 6. If I say C only, then that would be 20. And so there are certain questions that you can answer based on your diagram, but I need to see the diagram enclosed in a rectangle with all of the regions having a numerical value. A logic proof. So the different statements are, if I save money, then I buy a car. M implies C. If I do not save money, then I'll take the train. Not M implies T. Compound hypothesis. If I buy a car and a bike, is C and B in parenthesis, then I need insurance. Not I do not need insurance. I buy a bike is B. What you need to prove is I will take the train. So you start with a single statement by itself. You can't use B because it's embedded in a compound hypothesis. So I'm going to use not I, which is given. Then I take C and B implies I. Now the negation of the conclusion, not I, means the negation of the hypothesis, which is not, and then parenthesis, C and B. And that's modus tollens. And it's on lines 1 and 2. Now I negate that parenthesis, which is not C or not B. And that's by De Morgan's. On line 3. Now I can bring in B, which is given. And now, in a disjunction, B is given to be true, so not B is false. One of those two had to be true, or the disjunction would not have been true. Therefore, it must be not C, which is true, by disjunctive inference. on lines 4 and 5. And then I have M implies C, which is given. And the negation of the conclusion means the negation of the hypothesis again, which is modus tollens. And now not M implies T, which is given. So that now the final statement T is by modus ponens.